Okay everyone, let's continue looking at Module 26202-23, Motor Theories and Application in the NCCR 11th edition. This is Section 4.00, Motor Enclosures, Frame Designations, and Operating Characteristics. Motor Enclosures, Frame Designations, and Operating Characteristics. The National Electrical Manufacturers Association, or NEMA, classifies motors by enclosure size and frame designation to ensure interchangeability. Motors generally have covers over the moving parts called enclosures. If the cover has openings, it is called an open motor. If it has no openings, it is called a totally enclosed motor. Open motors are the most common type of motor. If the ventilating openings are small, the motor is considered protected. There are many common types of open motors, including general purpose, drip-proof, and guarded. Totally enclosed motor. This type of motor is designed to prevent airflow. Totally enclosed motors are generally used in hostile environmental conditions. There are many common types of totally enclosed motors, including non-ventilated, fan-cooled, and explosion-proof. NEMA frame designations. Frame sizes were developed to ensure interchangeability of motors among manufacturers. Motor nameplates list frame size and other key dimensions. Manufacturers create tables to correlate frame size to dimensions. Frame numbers for small motors is the D dimension in inches multiplied by 16. The letter after frame number denotes variations. Medium motors. The first two digits of the frame motor are equal to 4 times the D dimension in inches. The next digit of the frame number are obtained from a value of 2F in inches. The letters denote variations in the mounting and shaft orientation. Full load torque determines the required frame size for a motor. Motor ratings and nameplate data. The required information for motor nameplates is regulated in NEC 430.7. Some required ratings include voltage, speed, horsepower, and power factor. Nominal voltage is the voltage rating at which the motor is designed to operate. Minimal starting voltage is the lowest voltage at which a motor will start without drawing excessive current or tripping over protective devices. The nameplate voltage is the voltage at which the motor will operate most effectively. Amperage. The amperage nameplate rating indicates the current the motor will draw at nameplate, horsepower, frequency, and voltage. Rated full current load is the basis for determining proper cable sizing, overload protective devices, and other overcurrent protection in the motor circuit. Speed. The rated full load speed is the speed at which the shaft will turn at the nameplate horsepower when supplied with power at the nameplate voltage and frequency. If operating unloaded, the shaft will turn close to synchronous speed. Synchronous speed is rarely found on a motor nameplate. And in horsepower, an induction motor is essentially a torque generator. Torque is the twisting force of a motor. Horsepower specifies the rate of speed of torque. Horsepower is a rating used to specify the capability of an electric motor to produce mechanical power to drive a specific piece of equipment. If properly sized, most motors operate at less than nameplate horsepower. The NEMA design letter defines the starting torque characteristics of an induction motor. The difference in NEMA design letters is mainly the design of the rotor. Generally, the starting current is about 5 to 7 times the rated full load current. Insulation class. The electrical insulation system determines the motor's ultimate lifespan more than any other component. The insulation class identifies the class of material used to insulate the windings and defines the temperature the insulation can be subjected to without damage. When replacing motors, the insulation class should be equal or better. Frequency. Frequency of AC motors is given in hertz or cycles per second. The frequency of an AC motor in the United States is 60 hertz. Service factor. Service factor is a multiplier for the nameplate horsepower rating that determines the amount of overload that a motor can withstand. The most common service factor is 1.15. NEMA kVA code letters. The inrush or lock rotor current is the steady state current of a motor with the rotor locked in position and rated voltage applied. The letter corresponds to the kilovolt amperes per rated horsepower required during the first moments of motor startup. Lock rotor current is required when sizing fuses or selecting a circuit breaker. Bearings. Polyphase induction motors require anti-friction or sleeve bearings. Rated loads are higher at the drive-in of the motor, so drive-in bearings must have a higher load rating than the bearing at the opposite end. Power factor. The power factor is the ratio of active power of an alternating or pulsating current to the apparent power indicated by an amp meter and voltmeter. The power factor is a measure of the system or equipment efficiency. Duty rating. Duty or time rating is the elapsed time the motor can operate at nameplate horsepower without shortening its life. The most common duty rating is continuous duty, which defines that the load must be carried indefinitely. Intermittent duty or periodic duty and varying duty specify the short time rating, defining that the load can be carried for a specific time. And here are some trade terms that you should read over and become familiar with. And some review questions. A NEMA designation for a type of enclosed motor is splash-proof, drip-proof, explosion-proof, or guarded. I say explosion-proof. Using the frame designations, the distance from the motor feet to the shaft center line is known as C dimension, D dimension, F dimension, or S dimension. I'm going to say D dimension. What characteristic of a motor determines the ultimate lifespan more than any other? Horsepower rating, NEMA frame size, bearing size and type, the electrical insulation system. I'm going to say the electrical insulation system. All right, everyone, that's it for that section. The next section will be 5.00, connections and terminal markings for AC motors, and I'll see you over there.